Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about how to predict the products of neutralization reactions that involve compounds with carbonate ions in them. So let's get into this. So just like in my last video, I talked about how you can use the idea of, where you have ionic compounds, where you take the inside ions and the outside ions and put them together to form your possible products, right? And you can treat an acid as if it's an ionic substance and do that. In this case, it's the same, but here we got to be careful with regard to what products we're going to form because in some of these reactions, you can produce a gas, and these are the gas evolution reactions. So you have to remember or memorize or keep in mind what possible products are going to lead to gases or what possible products or are themselves gases. So for example, if one of your products is H2S, you have to recognize that that's a gas, right? Also, in this case, carbonates. Carbonates are responsible for producing carbon dioxide gas. So we have to recognize that. So I'm going to go over a couple of examples that show how the gas is formed and what products to look out for. So here we have our nitric acid and we have our magnesium carbonate aqueous. So here we're going to predict what the products are going to be. So we're going to do the outside ions and the inside ions go together. So here we have our H plus ion that's going to go with the carbonate. So the carbonate ion is a -2 ion. So we're going to need two H pluses to balance the charge on our carbonate. So we're going to get H3, oops, not H3, H2CO3, and that's going to be aqueous because you'll recognize that as an acid, that's carbonic acid. And then we're going to take the inside ions together, so we have magnesium and sulfate. The magnesium has a 2 plus charge on it. We know that because it's in group 2. Group 2 metals have a +2 charge on them because they're going to give away two electrons in their outermost shell, and that's what gives them the plus charge. So the nitrate ion has a -1 charge, so we're going to need two nitrate ions to balance the +2 on the magnesium. So that's going to give us MgNO3 2. And as we said before, if you follow the solubility rules, which you should be, all nitrates are soluble in water. Let me write this a little bit better. So again, we're going to have MgNO3 2, and this is going to be aqueous like so. And so now we have our two products. And so this is where, if you're not careful, you might misread this reaction and say, oh, it's no reaction. Why? Because I have two aqueous solutions on this side, and I have two aqueous solutions on this side, therefore no reaction, right? That would be the case if we had two ionic reactants on one side. Right here we have ionic. This is not ionic, it's covalent, but it will ionize into ions. And then if we had two ionic compounds here, so if we had two aqueous ionic compounds here, and then we ended up with two ionic compounds here that were both aqueous, yes, you would have a no reaction. But this is not an ionic compound, that is covalent compound. And this carbonic acid will break apart, will dissociate and decompose into water and carbon dioxide. So this becomes water, And if you subtract out the water from the formula, what you're left with is CO2. So here we have liquid water and CO2 gas, like so. So then you form three products. You got liquid water, carbon dioxide gas, and then you got that aqueous magnesium nitrate. But again, magnesium nitrate really isn't a product. It's not forming. These are just ions floating around in solution. These are what we would call the spectator ions. They're not participating in the reaction. They're just there. So the actual real products is going to be water and carbon dioxide. Okay, so next we have these two here. We have our sodium carbonate and we have hydrobromic acid. This is a strong acid. So again, we're going to do the outside ions together, inside ions together. So the sodium and the bromine or bromide ion goes together. So sodium has a +1 charge, bromide has a -1 charge, so 1 to 1. So that's going to be the formula. So NaBr. Okay. And then we're going to do the inside ion. So H is going to go with the CO3, the carbonate ion. Remember, carbonate has a 2 minus charge on it. So the H plus, we're going to need 2 of those to balance the charge on the CO3. So that's going to be H2CO3. So bromides are going to be soluble unless, of course, you have silver or lead 2 ions. The sodium is a group 1 metal. Those are always soluble. So this is definitely going to be soluble. So it's aqueous. And of course, this is an acid. So that's going to be aqueous as well. Once again, we recognize that we have carbonic acid. So anytime you have this, it's going to break down into water and carbon dioxide. So we have H2O, liquid, plus CO. Oops, I should write that better. CO2 gas. And so there's your products for this reaction. And that, ladies and gentlemen, is how you predict the products of neutralization reactions that involve compounds containing carbonate. So watch out for that. So I hope this is helpful. If you enjoyed this video, if this is helpful in any way, then please like the video, hit that like button, share the video with your friends. Also, subscribe to my channel. Hit that notification bell when you do. Make sure that you click all so you can be notified by all the videos I put out. And finally, put a comment down below. Let me know what you think. Ask me questions. If you have a problem you want me to go over, or a question you want me to go over, or if there's a topic you want me to do, I would love to do a video for that for you. Thanks for joining me and have a great day.